Welcome to BTEC Revision. In today's lesson, we're looking at power. By the end, we should be able to calculate the power of objects and calculate the instantaneous power of objects. What is power? Power is the rate of work done. And if you remember from last lesson, work done is the energy transferred. By rate, we mean divided by time. So the equation becomes power equals work done divided by time. So this is telling us how quickly an object can transfer energy in a given time. The short form of this equation is P equals W divided by T, and the units, power, is measured in watts. Work done is measured in joules, and time is measured in seconds. Looking at the equation, we can see that the units watts is equal to joules per second. For example, if we have two cranes picking up two separate boxes equal in weight, let's say 1000 newtons. Now, the first crane to pick this the same distance, let's say 10 meters. However, the first crane is going to have more power because it's transferred that energy in less time. Let's look at an example. A weightlifter transfers 2000 joules of energy when lifting weights, and this happens in a time of 5 seconds. What is the power of the weightlifter? The first thing we should do is write down the equation. Power equals work done divided by time. And we can plug in our values. Looking at the units, they are all in the correct form. So we can just simply put the numbers in. That's 2000 divided by 5, and that would give us a value of 400 watts. Next, we can look at instantaneous power. And instantaneous power is the power at any instant in time. And this can be calculated using the equation instantaneous power equals force times velocity. And the short form of this is P equals F times V. The units for power are still going to be watts. Force is measured in newtons, and velocity is measured in meters per second. Now let's look at another example. A car has a net force of 100 newtons in the horizontal direction and is moving with a velocity of 10 meters per second. Calculate the instantaneous power of the car. We'll start by writing down the equation. Power equals force times velocity. And in this case, the units are also correct. 100 newtons multiplied by 10 meters per second is going to give us 1000 watts. Now, pause the video here and attempt this exam question. A machine lifts a load of 500 newtons to a height of 10 meters in 20 seconds. What is the mechanical power output of the machine? We can start by writing down our equation. Power equals work done divided by time. Okay, we have time, which is 20 seconds, but we don't have work done. Instead, we have force and a height, and we need to get work done from these values here. So if we can think, last lesson, we looked at an equation that links work done with force and distance. Work done equals force times distance. So we can work that out through this equation from last lesson. Plugging in the values here, so that's 500 newtons times a height of 10 meters gives us a value of 5000 joules of work. Now we can plug this into our equation to work out the power, which is equal to 5000 joules divided by a time of 20 seconds and Our final answer is going to be 250 watts. And that's the end of the lesson. If you would like to boost your grades, try the quiz questions at btechrevision.com. See you next lesson.